Good morning, everybody, and welcome to the inaugural Symposium of the Southern Ocean Observing System, or SOOS. So my name's Elise Hancock. I'm the SOOS Executive Officer, so you've probably had lots of emails from me over the last little bit, and I'm the lead convener for the symposium. I'm delighted to welcome you all here to Hobart, Tasmania, home to the SOOS Project Office for over 12 years, so it's only fitting that we have our inaugural symposium here. The symposium is centred around the theme Southern Ocean in a Changing World, and this is incredibly timely given the critical changes that are currently being observed in the Southern Ocean. So we look forward to a week full of presentations, discussion and collaboration on everything Southern Ocean research, and to hopefully prioritise the next steps for the Southern Ocean observing systems. So to formally open the symposium today, I'm very honoured and humbled to introduce Sir Guy Green. Sir Guy originates from Launceston, Tasmania, and has lived for many years in Hobart. He's a highly respected judge, enthusiastic promoter of Tasmania, and advocate for Antarctic research. Sir Guy Green was Chief Justice of Tasmania from 1973 to 1995, served as Chancellor for the University of Tasmania in 1985 to 1995, and then was Governor of Tasmania from 1995 to 2003. During this time, he was also appointed as Administrator for Australia several times, and Sir Guy Green was knighted in 1982. During Sir Guy's time as Chancellor of the University, he played a critical role in the establishment of the National Multidisciplinary Institute for Antarctic and Southern Ocean Studies, or IASOS, which has later been transitioned to the now Institute for Marine and Antarctic Studies. Sir Guy has made a lifelong commitment to Antarctica, is the Honorary Antarctic Ambassador and current patron for Antarctic Tasmania. Sir Guy's dedication, advocacy and enthusiasm for Antarctic and Southern Ocean are remarkable. So please, join me in welcoming Sir Guy Green to the floor.
Well, thank you, Elise, for that introduction. I'd like to add my welcome to you all to this symposium. Opening this symposium is a bookend for me. I had my first encounter with SOOS in June 2015 when I opened the planning workshop for the implementation of the Southern Ocean Observing System. And today I'm delighted to have the honour of opening this inaugural symposium, which, given the range and significance of the topics to be discovered and discussed, and the standing of its participants, I'm sure will amply realise the promise raised by that workshop. Given that part of Tasmania, Macquarie Island, is located at 54 degrees south, right in the heart of SOOS territory, and given Hobart's standing as a leading hub of Antarctic-related research, education, resources and organisations, including, of course, the SOOS International Project Office itself, and given also the well-known modesty which Tasmanians display when they talk about their Antarctic assets, I don't think you could find a more appropriate venue for this symposium than Hobart. The first 15 years of the 20th century witnessed the heroic era of Antarctic and Southern Ocean exploration. Now, in this first quarter of the 21st century, we're witnessing the dawn of an equally heroic era of Antarctic and Southern Ocean science. And arguably the most significant development of that heroic era, Mark II, has been the demonstration of the reach of the influence which Southern Ocean processes have on the Earth system. This was a dramatic development indeed. To change the perception which we used to have of the Southern Ocean from being an excessively windy, very lumpy piece of water, safely removed from most population centres and safely corralled within the Antarctic convergence, into an ocean which has a worldwide influence out of all proportion to its size, was a revolutionary step which has transformed Southern Ocean science into global science. It's not an exaggeration to say that bringing together and organising an observing system which yields the data which sustain that science, SOOS is playing a centrally important role of truly historic significance. But in fulfilling that role, SOOS faces a number of challenges. Information, data and data sets are not knowledge. They are only converted into knowledge by scientific research. It follows that the data provided by SOOS have to be made findable and accessible and usable by the research community. But research scientists are not the only end users of the products of SOOS. They also include policymakers and those who fund research. That too raises several challenges for SOOS. When confronted by the sheer size and complexity and multifaceted character of the study of the processes of the Southern Ocean and their interaction with the rest of the world, SOOS end users can feel overwhelmed by something like intellectual agoraphobia. And those users include scientists who are only used to dealing with limited domains, precisely defined questions or precisely defined hypotheses. Difficulties are also felt by policymakers who are looking for immediate, straightforward, practical solutions to problems of a kind which SOOS simply cannot provide. Those who find Southern Ocean research, or those who fund Southern Ocean research, also find it difficult to cope. Their DNA makes them instinctively wary of the sort of open-ended projects of indefinite duration and correspondingly indefinite commitment of resources which are entailed in Southern Ocean research. In order to meet those challenges, it's necessary to help those scientists and funders and policymakers appreciate that although it uses the conventional methodologies of science, the study of the Southern Ocean and its global influence is qualitatively different from most other fields of scientific study. It's a field which has implications for the whole world, is multidisciplinary, poses questions which require cross-disciplinary examination, employs a variety of exotic technologies, needs long-term and large-scale programs of observation and monitoring, and a continuing process of analysing, storing, modelling and communicating data to an extent found in few other branches of science. Now, I think that one way of meeting those challenges is to draw upon what can be learned from the early history of Antarctic science. In the 19th century, apart from those who were mainly interested in taking seals and whales, some 24 scientific expeditions to the Southern Ocean and the fringes of the Antarctic continent were undertaken. Now, although some of those expeditions had fairly specific questions to address, such as testing the hypothesis that no living organisms existed in the deep ocean, or what was the source of sea ice or icebergs and so on. They took the view that simply investigating and recording the properties of the Southern Ocean and its biota was sufficient justification in itself for the investment of the time and huge cost involved. Now, history has vindicated that view that they took. The accumulation of the mountains of data they derived from their observation of ice and wind and ocean currents, the temperature and salinity of the ocean at various depths and so on, laid the foundations for 20th century climatology, earth science, oceanography, the study of ecosystems, and much more. Now, I'm not suggesting that Sue should be defensive about what it's doing, or should adopt the somewhat random 19th century strategy of having a flotilla of different expeditions undertaking what were often rather unstructured programs. But what I am suggesting is that SUSE and its end users can draw inspiration from the 19th century recognition of the fundamental necessity for obtaining and organising data about the Southern Ocean, even when the benefit of doing so is not immediately recognised or appreciated. Another challenge arises from the fact that the end users of SUSE products are not confined to the research community and policymakers. They also include the wider community. And that's so, first, because the scientists and policymakers are ultimately accountable to the society which sustains them. Secondly, because in modern education societies, I think that it's intrinsically desirable that the wider community be kept informed of large-scale enlargements of knowledge of the kind which SUSE generates. But keeping the wider community properly informed requires skill. Material needs to be simplified, but not to the extent that it becomes misleading. And there's no reason why such material shouldn't touch on the social implication of scientific conclusions, provided, of course, it's not disfigured in any way by ideology, although I'm sure that there's no risk of that with SUSE. There is a place for that in other discourse, but not in objective scientific advice to decision makers or the public. A small but important detail is that material should usually be accompanied by a glossary. That's not only hopeful for the lay reader, but in this multidisciplinary field, it's important to ensure that those in different fields are using the same terms in the same way. It's also helpful, I think, if the glossary includes Antarctic acronyms. However, you must bear in mind your occupational health and safety duty to guard against spreading what I call chronic Antarctic acronym fatigue syndrome, or CAFS. Let me conclude by making a prediction. When the history of 21st century Earth science comes to be written, the advent and the work of SUSE will be the subject of a very prominent chapter indeed. I hope you all have a productive and interesting symposium, and I hope that our visitors enjoy their stay in Tasmania. It's with great pleasure that I declare the inaugural symposium of the Southern Ocean Observing System open.
Thank you very much, Sir Guy Green, for a beautiful opening of the symposium, and I think greatly sets the scene for this week. So the Seuss Symposium is meeting on Nipaluna, or Hobart, Litruwita, Tasmania, the land, sea and waterways of the Muanani people, who are and always will be the traditional owners of this land. So I'm very honoured to now introduce Auntie Brenda Hodge, a proud Palawa, Tasmanian Aboriginal person who will welcome us to the country this morning. Thank you.
Thank you, Elise. Ya, Pulingana, Miladina, Mana, Mapali too. Hello, welcome to all of you here on our land. I'm a proud Trawulway woman, descended from Manalagena and the Parabeni people from Tipukuna in northeastern Tasmania. I show respect to my elders, past, present and emerging. I respectfully acknowledge the traditional custodians of this land on which we gather today, the Muhanina people, who belong to the oldest continuing culture in the world and who roamed this land for more than 60,000 years. Nipaluna Hobart was their country. They called our mountain Kunani and our river Team Tumili Minanya. It is a privilege to stand on their country. Muanina Leikara Miladina Kipli Mulaka. It was here that the Muhanina hunted for food. Miladinata Ne Api Nara Mapali. Miladinata Krakapaka Nara Mapali. They gave birth on country, they died on country. Lumi Ningimpi Mana Mapali. Nangampi Mana Mapali, Lurina Warranta Mapaya, Winina Nara Mapali, Warranta Ninina Nara Mapali, Paywuta Niakara. Our ancestors are still here. We feel them all around us. They give us our dreaming. Warranta Takara Miladina Nara Mapali Takara. We walk where they once walked. Miladina Nika. This is our country. Miladina Mana, this country is us. Warranta Palawa Miladina Nika, we are this country. With pride and on behalf of our ancestors, I welcome each of you to Aboriginal land, Nipaluna Hobart, Lautrawita, Tasmania. I wish you every success for your symposium this week and for the future. Nairi Ninatu Mapali. Thank you, everyone.
Thank you, Auntie Brenda, and please everybody join me in paying our deepest respects to the traditional owners of this land, to the elders past and present, and to the many people of the Tasmanian Aboriginal community that continue to care for this country. Seuss is an initiative of the Scientific Committee on Antarctic Research, SCAR, and the Scientific Committee on Oceanic Research, SCORE. We'll now have a welcoming address from the SCAR President, Dr. Yadong Kim, and the SCORE Executive Director, Dr. Emily Twigg.
Dear distinguished speakers, colleagues and participants, I would like to extend my warm welcome to the inaugural Seuss Symposium 2023. It is with great excitement and honor that I stand before you today as we mark a significant milestone in Antarctic and Southern Ocean research, especially with a focus on expanding our understanding of the Southern Ocean. This symposium is the very first of its kind since the establishment of Southern Ocean Observing System more than a decade ago, born as a collaborative initiative between the Scientific Committee on Antarctic Research and Scientific Committee on Oceanic Research. Seuss has been at the forefront of interdisciplinary research, long-term observations, and international cooperation in the Southern Ocean. As we convene here today, we acknowledge the immense value and responsibility we bear in studying and safeguarding the Southern Ocean within the Earth system. The theme of this year's symposium, Southern Ocean in a Changing World, serves as an alerting reminder of the critical role this vast expanse of water plays in shaping our planet climate and the marine biodiversity. Drawing upon the comprehensive SEWS Science and Implementation Plan for the 2021-25, we have an opportunity to assess the progress we have made thus far in developing observing system, collecting comprehensive observations, and implementing regional program. While significant data gaps still remain in the Southern Ocean, together we can reflect upon our achievement and address the challenges we face in providing long-term observations that contribute to policymaking, societal concern, and advancement of scientific knowledge in the Southern Ocean. I would like to also take this opportunity to highlight the work of SCA, SEWS, and our partners on the United Nations Decade of Ocean Science for Sustainable Development and Initiative. Since 2021, SCA has been working in close partnership with SEWS and various partners such as SCORE, WCRP, IATO, and more to develop what we call the Southern Ocean Action Plan that provide a framework for stakeholders to develop tangible action and deliverables, encouraging collaboration between science, industry, and policy to address knowledge gap and improve data coverage in the region. SCA is delighted to work with SEWS and our partner through the UN Decade of Oceans initiative to gather stakeholders worldwide and strengthen international cooperation to support sustainable development of the Southern Ocean. Moreover, in June of this year, SCA has been officially endorsed as a Decade Collaborative Center for the Southern Ocean region by the UN Decade of Ocean Science. This collaboration underscores our shared commitment to advancing scientific knowledge and understanding of Southern Ocean, particularly in the face of ongoing environmental change. As a Decade Collaborative Center, SCA will act as a coordinating body for a number of international science programs dedicated to observing the Southern Ocean, such as the newly proposed Antarctic InSync initiative, and will continue to strengthen its cooperation with SEWS to foster international cooperation and promotion interdisciplinary research and facilitate long-term observation in the Southern Ocean, all in alignment with objectives of UN Decade of Ocean Science. As we gather here today, I'm also very proud to welcome a diverse list of speakers who brings a wide range of perspective, experience, and expertise to the symposium. SCA and SEWS strongly value and uphold the principle of equality, diversity, and inclusion, and we firmly believe that fostering an inclusive environment is essential for robust scientific discoveries and breakthrough discoveries. In this spirit, I also extend a special welcome to early-stage researchers who are joining us to share the valuable insight and contribute to the collective knowledge of Southern Ocean. Their fresh perspective and enthusiasm are invaluable asset to our endeavors, and we encourage their active engagement and participation throughout this symposium, including during the last session on the gaps and next step for SEWS on the final day. Finally, let's recognize and celebrate the exceptional contribution of Tasmania to Antarctic research. Situated at the gateway to the Southern Ocean, Tasmania has long been a center for scientific exploration and discoveries in the Antarctic region. I would like to thank University of Tasmania's Institute for Marine and Antarctic Studies for playing a pivotal role in advancing our understanding of the Southern Ocean and also hosting the SEWS International Project Office. Tasmania's strategic location and unwavering commitment make it an invaluable partner in international effort to protect and sustainably manage this precise ecosystem. As we embark on this inaugural symposium, I extend my sincerest wishes for a resounding success and fruitful exchange of knowledge and insight. May our discussion be characterized by insightful debate, constructive dialogue, and groundbreaking discoveries. Together, let's seize this unique opportunity to build new partnerships, inspire innovative solutions, and collectively contribute to the conservation and sustainable management of the Southern Ocean. I would like to close by expressing my deepest gratitude to the symposium conveners, Dr. Sian Henry, Aileen Hoffman, co-chairs of SU's Scientific Steering Committee, and all the vice chairs, as well as Dr. Alice Hancock from SU's IPO, and also to all our colleagues in the organizing committee whose meticulous planning and unwavering commitment to the excellence have made this inaugural gathering possible. Your dedication and vision have set the stage for us to come together and embark on this historic journey of exploration and collaboration. Once again, I welcome you all to the inaugural SUS Symposium 2023 with open arms and eager anticipation for knowledge and insight that will be shared. Let's make this inaugural symposium a resounding success and lay the foundation for the continued progress in our understanding of the Southern Ocean. Thank you very much.
Thank you to Dr. Yedong Kim, and now we'll have a welcoming address from the Executive Director of SCORE, Dr. Emily Twigg.
Thank you for inviting me to share my welcome and my remarks of support for SUS and the information exchange facilitated by this symposium. On behalf of SCORE, I'd like to express appreciation and welcome to everyone who has joined this event to participate in international cooperation and coordination for conducting observations in the Southern Ocean. I am Emily Twigg. I only recently started as Executive Director of the Scientific Committee on Oceanic Research, but I'm happy to be able to reflect on SCORE's longer relationship with SUS briefly with you today and make you all more aware of SCORE. Together with SCAR, the Scientific Committee on Antarctic Research, SCORE has supported SUS since its formal inception in 2011 and the drafting of the initial science and implementation plan. Since then, SUS has made great strides in connecting researchers in the Southern Ocean. SUS has brought the community together to develop priorities and fill gaps through working groups and task teams, working on developments such as the prioritization of the ecosystem EOBs, and also encouraging data integration and sharing and facilitating it through SUS Map. With Due South, SUS has created a user-friendly platform to identify collaborators in data collection. And now here we are at the first symposium held by SUS, which I think will be a huge leap in opportunities to increase collaborations in the SUS network. SCORE's mission is to promote international cooperation and develop global capacity in the ocean sciences. It is a non-governmental, nonprofit organization established in 1957 by what is now known as the International Science Council, like our partner SCAR. It is funded by membership dues by currently 32 members and from national and international agencies and organizations. That includes the host institutions for international project offices, such as the Partnership of Hosts for SUS. SUS is a major component of SCORE's contribution to activities in the Southern Ocean. SUS is one of SCORE's infrastructural projects in that SUS provides the supporting structure for research, observations, and modeling, which may otherwise be challenging to find funding for. SCORE also supports large-scale research projects, smaller-scale working groups on focused topics, and capacity development. SCORE's efforts in the broader international ocean science community also make contributions and have connections to SEWS. For example, IMBER, the project on integrated marine biosphere research, co-sponsored by SCORE and Future Earth, has the regional program ICE, Integrated Climate and Ecosystem Dynamics in the Southern Ocean. ICE engages with SEWS directly in order to facilitate the availability of the observations necessary to understand the integrated Southern Ocean ecosystem. Key science challenges relevant to the Southern Ocean are addressed by other large-scale projects supported by SCORE. These include, but aren't limited to, SOLAS, the Surface Ocean Lower Atmosphere Study, and IOCCP, the International Ocean Carbon Coordination Project, and many short-term working groups funded by SCORE can directly or indirectly support SEWS when they focus on improving measurements or modeling of ocean parameters. One such example is ECV ICE, which is synthesizing standardized protocols for processing sea ice samples and collecting data for key variables, including CO2 partial pressure, nutrients, algal biomass in production, and gas exchange. SCORE is here to be a mechanism for interaction where needed and support SEWS further through these relationships and opportunities. SCORE also encourages involvement of early career scientists and scientists from developing countries to increase their capabilities in the ocean sciences, both through SCORE's projects and working groups, as well as in capacity development programs. To this end, SCORE provided a grant to support early career developing country scientists to attend this symposium. It's also great to see the early career perspectives invited to the symposium's closing session as we think about the future. A diverse and inclusive community with participation by people from all geographies and career stages and points of view is critical for achieving goals that rely on unity and cooperation. Activities in the Southern Ocean are made stronger when everyone is included. I'd like to tie everything together with how SCORE provides opportunities that can be taken advantage of by those of you at the symposium to support your work in the Southern Ocean further. Anyone can propose or be part of a new working group on a focused scientific question. Linkages to existing projects are always welcome. New working groups are selected for funding every year. Established scientists can apply to be a visiting scholar in a developing country, to provide a short course or on-site education. Similarly, institutions interested in hosting can seek visiting scholars. With POGO, SCORE provides fellowships for developing country scientists to visit other oceanographic centers for training. Meeting organizers can apply for travel grants to support attendance of early career scientists from developing countries at meetings or trainings in the ocean sciences, such as was done for this symposium. And this is available on an ongoing basis in advance of your meeting. Large-scale projects renew membership of their scientific steering committees and engage many scientists to fulfill their goals that people can seek to be a part of. SCORE has an early career member on the executive committee for 2-year terms, and the next applications will be requested in 2024. Lastly, you may be able to engage with your national committee, or if your nation is not a member of SCORE, I'd be happy to work with anyone to find a means to pursue membership. You can follow SCORE by joining the email list and visiting the website to track announcements about these opportunities. Perhaps you will have these opportunities on your mind as you plan new efforts with colleagues this week. As is reflected in the symposium theme, understanding the Southern Ocean becomes more and more critical every year as climate change continues. These changes were recognized at the founding of SEWS and continue to progress. Thank you for being here to contribute to this pressing topic. And thank you to the International Project Office and the organizing committee for all the work that went into planning this event. So thank you and welcome.
Thank you to Dr. Emily Twigg, and thank you also to SCAR and SCORE for their ongoing support of the Southern Ocean Observing System. So I'd just like to take a few minutes to say a couple of very quick thank yous and then some housekeeping items for this week before our opening plenary. So firstly, thank you to all of our sponsors, supporters who have made this SUS Symposium possible. Please make sure you check out their profiles in the Symposium app. And then on Wednesday and Thursday, we'll have an exhibition running. So some of the sponsors have an exhibit, but also we've got a number of exhibitors as well. So please make sure you go and check out their exhibits. Just like to give you a quick overview of the program for this week. So for most days, we're bookended with a plenary at the start and the end of the day, with parallel sessions through the middle. I want to highlight a couple of data activities running through our parallel sessions. So today we have a Creating Impact for your observational research, your observational data beyond research workshop. This is followed then on by a SUSMAP workshop, which is SUS's data discovery tool. On Tuesday, we've got a workshop on Polydex and Due South, which is the European Polar Board and SUS's infrastructural database. And then on Thursday, we have got the workshop on SUSMAP running again, and the SUS's Data Committee are running a data surgery. In addition, during the day on Wednesday, the SUS's Data Committee are nicely holding a SUS data help desk. So for any of your data needs, please feel free to go and visit them on the Wednesday and they can help you out. In addition to our program running through our plenaries and parallel sessions, we also have lunch meetings every day of SUS's working groups. All of these lunch meetings are open, so if you're interested in the activities of any of our working groups, please do attend these lunch meetings. We've also got a mentoring program running throughout the symposium. So for those involved in the mentoring program, during the morning tea, if you could please join me over that side of the mezzanine. I'll try and have a flag or something so you can see me, so that we can meet your mentors and mentees together and run a short ice-breaking activity. Through the symposium, we've also got a pilot hybrid running. So through the program, you'll see some of the parallel sessions are highlighted in blue. These are the ones that we've got some live streaming happening. We also have an ECR networking event running this evening from 5:30 to 7:30. So for all of our early careers, on registration you should have got 2 tickets. If you didn't, please go see Helene and the team at the registration desk. These tickets are for one for yourself to enter and one for you to bring an invited guest to enter as well with you. So there's someone you've always wanted to chat to and meet. Please do come and invite them tonight. There will be some food and drinks on, and this will be happening at the Tasmanian Museum and Art Gallery. But we will gather here today at the end of the last plenary to then walk over together. On Tuesday, we have our poster session running. So for all those with a poster, please pop your poster up on Tuesday morning, or the catering will be across in a different space where the posters are, and then we'll have our poster session on Tuesday night. So for all the poster presenters, if you can stand by your poster Tuesday night, that would be great. And then our symposium dinner is on Wednesday night out at Franklin Wharf. It's quite a packed program, so we've given you Friday afternoon off so you can hopefully take advantage to enjoy Hobart and Tasmania, and for those have a bit of a break that are then joining us for our Scientific Steering Committee on the weekend. We have a code of conduct for the symposium. This was available through your handbook and also on the symposium website. And so we aim to have this symposium as welcoming, respectful and inclusive and collaborative as possible. So this code of conduct provides a set of guidelines and expectations to make sure that we've got an inclusive and productive environment. Obviously, we want to foster positive discussion. We understand that everybody is going to have slightly different points of view, but hope that all participants can respect the views of others and have positive, respectful discussions. So just some key points. We expect everybody to treat everybody else with respect, to be considerate of your physical surroundings and your fellow participants, and please adhere to the rules and policies of the meeting venue here and for the meeting venues of any of our side meetings. We have 2 safety officers for the symposium, myself and Kathy. If Kathy could please stand now. So if you've got any concerns, if there's any problems where someone hasn't acted in accordance to the code of conduct, please come and see Kathy or myself. We can also be identified by a red strip on our lanyards. Or you can also submit this electronically to info@seuss.aq. And we've got a number of teams coming in to support us for anything needed here. But obviously, we expect everybody is going to act beautifully and in accordance to our code of conduct, so hopefully we're not needed at all. So along this vein, I'd now like you to turn to your neighbour and say what you're actively going to do during the symposium to make sure that it's welcoming, respectful and inclusive and collaborative for everybody. Okay, fantastic. Well, with that great enthusiasm, I'm looking forward to a fantastically inclusive symposium. We also have a Slido account running for the symposium, so if you don't want to ask a question verbally, or for those that are joining in online, you can ask a question through Slido. You can also ask this anonymously as well. So please, there's a QR code here. We'll also be showing this through the event to ask your questions through Slido. When you enter the app, please do check at the top right that you're selecting the correct room. So for plenaries, we're in the plenary room, and then for the parallel sessions, you'll need to select Grand Ballroom 1, 2 or 3, and if you're not sure what room you're in, it's shown at the door on the entry and also on our program. Lastly, we will have a special issue coming out for this symposium, and this will be through Elementa. So please stay tuned for more information around this special issue and how you can contribute. So now, I'm greatly honoured to introduce our opening plenary for the symposium, the need for a Southern Ocean observing system. So the Southern Ocean plays a critical role in the Earth system, and our understanding of the ongoing changes and our ability to project future changes are reliant on sustained observations. SEUSS has built a strong network of community-driven initiatives and tools that combine and enhance and facilitate the delivery of a sustained observing and data delivery system for the Southern Ocean. This opening plenary will be in 2 parts. The first given by Steve Rintoul on the establishment of SEUSS, how we got here, and then this will be followed on by a presentation from our current co-chair Eileen Hoffman on our current activities and contributions to Southern Ocean research. Dr. Steve Rintoul is a physical oceanographer and climate scientist at CSIRO and the Australian Antarctic Program Partnership here in Hobart. His research is focused on the role of the ocean in the climate system, with a particular fascination for the Southern Ocean. He uses observations from ships, floats, moorings, seals and satellites to investigate the dynamics of the Antarctic circumpolar current, the overturning circulation and ocean ice shelf interactions. He's led 15 expeditions to the Southern Ocean and has coordinated major international Southern Ocean climate research programs, including the Southern Ocean component of the World Ocean Circulation Experiment, CLIVAR, and the International Polar Year in 2007 and 2008. Dr. Rintoul's scientific achievements have been recognised through many national and international awards, including the Martha T. Muse Prize, an Australian Antarctic Medal, and the election as a Fellow of the Australian Academy of Science. As an organiser of the 2006 meeting in Hobart that seeded the idea for the Southern Ocean Observing System, and the lead author of our first science plan in 2010, as well as being an inaugural SEUSS Scientific Steering Committee member, Steve is perfectly positioned to give the opening plenary of this symposium. So please join me in welcoming Dr. Steve Rintoul.
Thanks, Elise, for that kind introduction. And I would also like to pay my respects to the Muinina people who, as we heard, for 60,000 years as custodians of the land and sea country on which we meet, were stewards of the land. And when you think about 60,000 years of stewardship compared to what we've done in the past 200 years, it puts that into context and perhaps provides pause for thought. So my topic is a brief history of Seuss. I just realized I didn't figure out where the clicker is. Is this my clicker? Okay. So my job is to remind you all how we got to where we are today. And I'll focus more on the ideas behind Seuss, where they came from, and the broader context in which they came about, rather than a sort of programmatic view. And what I'll talk about today is obviously the product of many of you in the room and many others who are not here today. So the story really begins. Oh, that big green button. Back in 1982, in a sense. In 1982, it was the strongest El Nino we'd ever seen. It was completely unanticipated. We didn't have models that could predict El Nino, and we didn't have observations that could tell us it was happening at that time. It caused widespread devastation around the world, floods in some places, droughts in others. More than 1,500 deaths, more than $4 trillion in lost income globally. In Australia, there was very intense drought, bushfire, and loss of homes and lives. And this inspired or kicked along a program called TOGA, the Tropical Ocean Global Atmosphere Program, which set out to allow us to do better, to be able to predict El Niños and La Niñas before they hit us so that we might be better prepared for their impacts. A crowning achievement, there were really two crowning achievements of TOGA. One was that by the end of the TOGA decade, we were able to predict El Nino and La Nina events to some extent, at least much better than we had before. And also the establishment of a basin-wide observing system in the tropical Pacific. More than 70 moorings, ships, and satellites together meant that for the first time ever, we had a system to measure a large fraction of the world ocean. Skip ahead to the early 90s, which is really the dawn of global oceanography. After the work on TOGA, people began to think maybe we really needed to measure the rest of the ocean if we were going to do the global climate problem. And the World Ocean Circulation Experiment really set out to collect a snapshot, in quotes, a blurry, decade-long snapshot of the world oceans and what they did in terms of climate. That was possible in part because of the dawn of the age of satellite altimetry, with Topex Poseidon launched in 1992, providing, to the present day, continuous measurements of sea surface height globally. The third picture shows the WOS sections in the Southern Ocean. That really laid the foundation on which much of Seuss remains built. And on the right are trajectories of ALICE floats. ALICE stands for Autonomous Lagrangian Circulation Explorers. For most of you in the room who have come of age during the period of Argo, it might be stunning to imagine that we put 1,000 floats into the ocean with the purpose, really, of following their drift. The idea was to measure the circulation. We didn't even measure temperature and salinity as the floats went up and down. So things have evolved, and that's one example. 1990 was also the publication of the first IPCC assessment. It was a call from the IPCC and the World Climate Conference for a global ocean observing system. TOGA ended. WOS was about halfway through, and the Climate Variability and Predictability Program, CLIVAR, was on its way. And CLIVAR very much had a focus on variability of the climate. Could we predict that variability? And could we do a better job of projecting the changes due to climate change? At that time, the Southern Ocean was not really seen as central. For most of you in the room, you probably start your talks or papers with a throwaway line like the Southern Ocean has a profound influence on global ocean circulation and climate, or something like that. That wasn't true in the mid-90s, and the CLIVAR Science Plan, as an example of that, recommended an exploratory approach to the Southern Ocean. It might be important, it was a long way away, it was going to be hard. We'll go slow on the Southern Ocean. Next big event in the history is the 97-98 El Nino, which set a new record. This was predicted. The TOGA system had worked. We knew it was coming. I don't know much about this, maybe because people weren't used to using climate predictions yet, but those predictions didn't allow us to avoid serious impacts. 23,000 deaths, $5.7 trillion in global income loss. In a tone-deaf way, the CLIVAR implementation plan in 1998 described this event as a wonderful natural experiment for CLIVAR scientists to watch unfold. In 97 was also the UNFCCC meeting in Kyoto that led to the Kyoto Protocol. First global step, maybe, towards taking some action about climate change. It was also the beginning of the global ocean data assimilation experiment. Data assimilation was commonplace in the atmosphere by then, but it was not being done in the ocean because we didn't have global ocean data sets to assimilate. And the dawn of altimetry and float data and others were meant that that was now possible to conceive of. And in 97, we were also thinking a bit about the overturning circulation and its importance in the climate system and its possible sensitivity to the changes that were coming with climate change. 99 was an important year. It was the first Ocean Ops Conference, and at that conference was the first community white paper that made the case for sustained observations of the Southern Ocean. It was also the dawn of Argo around that time. That's when the Argo program began. And the first meeting of a CLIVAR, CLIC, SCAR Southern Ocean panel, and much of that panel over the ensuing years did a lot of discussing of the need for sustained observations of the Southern Ocean. We were still a little defensive about the Southern Ocean at that point. This quote came in the final remarks of that white paper. Basically made the point that you guys better not forget us because we can't do the global problem without doing the Southern Ocean, and just because we're far away and a long way from the densely populated Northern Hemisphere, you better remember the Southern Ocean. It's kind of hard to think now that we felt that was necessary, but we did it at the time. So on to 2006, and the first time that the Seuss name was used in, to my knowledge anyway. A workshop was held with some pushing from Tony Hammett, who's here or will be here, and the Partnership for Observations of the Global Ocean, which is essentially a club of the directors of all the world's marine science institutions. And the purpose of the workshop was to consider the case for establishing a Southern Ocean observing system. Was it necessary, and did we want to do it? The answer wasn't obvious, at least to me. I, in fact, argued against it. I thought it was potentially bad strategy because what we needed was a global ocean observing system. And we needed to keep focusing on the need for global observations that truly covered all of the global oceans, the marginal seas, from pole to pole. It needed to be global, and that if we cut off the Southern Ocean bit, it might be easier to isolate. It might make it harder to get support rather than easier. I was wrong, and I was convinced at the time that we should go ahead, and I think that was the right choice in retrospect. The picture of the seal with a CTD sensor attached to its head is in this particular slide because it was at this time that that technology was really coming of age and had been proven. And the workshop was heavily attended by seal biologists and strongly endorsed the concept of that seals could make an important part to a Southern Ocean observing system, which might explain the wide smile on Mark Hindell's face on the right-hand side of this photo. Tony Hammett's on the left, a much younger Steve is in the orange top. Colin Summerhays is in the middle, who from SCAR, and Ed Urban from SCORE had a lot to do with knitting those two organizations together. They were quite separate before then. Victoria Wadley and Mark. That team was asked to take the Seuss forward and help make it happen. The timing was perfect in a sense because 2007 to 2009 was the International Polar Year. And it really provided a proof of concept that Seuss could be done. It was feasible, it was affordable, and it was needed. And it really provided a kick along. It was kind of a test run of the Seuss idea. The Climate of Antarctica and the Southern Ocean, or CASO program, basically repeated the WOS survey that had taken a decade during WOS inside of less than 2 years. The Synoptic Antarctic Shelf Slope Interactions, or SASI program, looked at the shelf and slope around Antarctica circumpolarly. That had really been missed by previous programs. The Marine Mammals Exploring the Ocean Pole to Pole, or MEOP program, collected 67,000 profiles during the IPY, and Argo, which was rapidly growing through that period, also provided about 60,000 profiles. Given that in the WOS era, the total number of oceanographic profiles in history was less than 10,000, this was obviously a major step forward. So that brings us to 2012 and the first science and implementation strategy for SEUS. And in 2011, the International Project Office was established here in Hobart. So we were truly a respectable program now. We had an IPO. That strategy identified 6 themes. First, the role of the Southern Ocean in the planet's heat and freshwater balance. Second, the stability of the Southern Ocean overturning circulation. Third, the role of the ocean in the stability of the Antarctic ice sheet and its contribution to sea level rise. Fourth, future and consequences of Southern Ocean carbon uptake. Fifth, the future of Antarctic sea ice. And sixth, the impacts of global change on Southern Ocean ecosystems. Those themes, we argued, could only be answered if we had sustained, broad-scale observations of the Southern Ocean. And so the scientific motivation was really based on that, those themes, and I'd like to dig into that a little more now. This depiction of the global ocean overturning that Bill Schmitz published in 1996 was highly influential. It placed Antarctica and the Southern Ocean in the center where it belongs and emphasized the important role that the Southern Ocean plays, the circumpolar flow around Antarctica plays in connecting the ocean basins and therefore allowing a global scale overturning circulation to exist. But in addition to that role, it connected the upper and lower limbs of the overturning circulation. So at that time, by the mid-90s, we'd spent 50 years thinking that the way the overturning circulation worked is that dense water sank near the poles and it bubbled up slowly throughout the ocean interior. When we finally got around to measuring interior mixing, we found it was an order of magnitude too weak to support the level of upwelling required, so something else had to connect the deep and shallow limbs of the overturning. And we found out we realized that that was the Southern Ocean, where deep layers of the ocean shoal as they spread poleward towards Antarctica, reach the atmosphere and the ice, interact, and are transformed either into lighter intermediate water, which returns to the north, or denser Antarctic bottom water, which is also exported to the north, forming this global overturning circulation. So given the importance of the overturning circulation, which we knew at that time, in terms of setting the capacity of the ocean to store anthropogenic heat and carbon and therefore slow the rate of climate change in response to greenhouse gas emissions, that really put the spotlight on the Southern Ocean as a crucial area to measure and to understand to do the climate problem. We'd known that eddies were important in the Southern Ocean for a long time, but our understanding in the lead up to publishing this strategy was developing quickly. The plot on the right, which will distract all of you while I'm speaking so you won't hear anything I say, is a lovely animation by Ryan Abernathy of what happens when you blow wind and exchange heat, cool and warm, the surface of a channel ocean. Isopycnals steepen, you form a circumpolar current. The steep isopycnals go unstable, form eddies, and those eddies transport many properties, mass, heat, and momentum, and others. And that helps establish the Southern Ocean circulation, both the circumpolar current, but also the overturning circulation. And two concepts, eddy saturation and eddy compensation, became popular around this time. Eddy saturation to express the dynamical observation or understanding that when you blew more wind on the circumpolar current, you didn't make it go faster as we used to think, but instead the eddies tended to keep the ACC transport. When you blew more wind, you got more eddies, but the transport stayed the same. Eddy compensation, a related concept, was about how the eddies acted to compensate the wind-driven circulation. And so if we're interested in the net overturning circulation, we needed to take both the role of the eddies and the contribution from the eddies and the contribution from the wind into account. As a result of that overturning circulation, the Southern Ocean takes up a lot of anthropogenic heat and stores it in the Southern Ocean. And we now know that that number is more like 75% of the global ocean heat uptake enters the ocean through the southern, mid to high latitude southern hemisphere oceans. And given that we know that the ocean stores more than 90% of the extra heat that's been stored by the planet over the last 50 years or so, the Southern Ocean is an important part for climate for that reason as well. And of course, it's not just about heat. We also realized around this time, Chris Sabine's paper in 2004 was also very influential, showing that the Southern Ocean took up and stored a lot of anthropogenic carbon as well. In this map, you see that the North Atlantic is a hotspot, but integrated around the globe, the Southern Ocean takes up more heat, more anthropogenic heat and anthropogenic carbon dioxide than any other latitude band. So if we want to do climate, we better understand it. So I better go back one, if I can. Of course, a consequence of that storage of heat and carbon, which is doing us the service of slowing climate change, comes at a cost, as I don't need to remind this audience, with the cost of warming being sea level rise and the cost of carbon uptake being acidification and changes in the concentration of carbonate ions, making life difficult for organisms like pteropods that form shells out of calcium carbonate. In WOS and even the early days of CLIVAR, there was really very little attention paid to the role of the Southern Ocean in influencing the Antarctic ice sheet. But around this time, as we were developing these ideas about what ASUS needed to do, the idea that the fate of the Antarctic ice sheet was dependent on the ocean was becoming better understood. This figure by Eric Reno shows in the red dots where Antarctica is losing ice, and the blue dots show where it's gaining ice. And where Antarctica is losing ice is where warm waters reach the base of the ice shelves, something that was followed up by Hamish Pritchard and showed that really the ocean, the fate of the ice sheet depended on the surrounding ocean. And SEUS, again, unlike some of the other programs I've spoken about, like WOS and CLIVAR, included a specific emphasis on Southern Ocean ecosystems. The strategy noted that the Southern Ocean food web was both productive and unique in its dependence on the keystone species krill, and that the ecosystem was also shaped by the physics and biogeochemistry. So this bioregionalization prepared by a process led by Andrew Constable showed that the ecosystems depended on the environment in a very explicit way, but we didn't really understand it very well. And in particular, as the quote from the strategy shows, if we really want to manage marine resources in a sustainable way, we need to be able to know what's due to harvesting and what's due to climate. And we didn't have the observations needed to do that. So that's why the Southern Ocean was important. And given that importance, if the Southern Ocean was changing, it would have widespread and significant consequences. And indeed, at that time, we were beginning to get a handle on how the Southern Ocean actually was changing. It was clear that the Southern Ocean was warming. Sarah Gilly and Klaus Berning used floats compared to historical data to document the rates of warming in the upper ocean, while Sarah Perky and Greg Johnson were publishing their first studies showing global maps of the warming of the abyssal ocean, with the largest warming near the Antarctic continent. There's also clear evidence of freshening. Stan Jacobs' more than 50 years time series in the Ross Sea showed a steady freshening trend of the shelf waters on the Ross Sea. The float showed that the ACC region was freshening as well in the upper ocean, and the bottom water was also freshening and getting lighter, as shown in the plot on the right, going from green to blue to red between 1970s and 2005. Sea ice was also changing, with ice being lost in the Bellingshausen and Amundsen seas and growing and lasting for a longer period in the Ross Sea. Changes that those we talked a lot at the time about how the extent of Antarctic sea ice was slowly increasing, very slowly increasing. But that statement masked these regional changes which were at a rate that was comparable to what was going on in the Arctic. Thompson and Solomon's paper in 2002 was also very influential at this time. We knew about the southern annular mode, or what it used to be called the Antarctic Oscillation, as the primary mean mode of variability of the southern hemisphere atmosphere. But we're only then really beginning to appreciate the trend in that mode of variability, that is a tendency for westerly winds to strengthen and shift poleward, and that those shifts in winds had very strong consequences for the underlying ocean and sea ice. We didn't have many observations of over time of Southern Ocean ecosystems, but we did have some fragments. Atkinson et al. Showed that the decline in sea ice west of the Antarctic Peninsula was reducing krill numbers downstream, and that was associated with a shift to greater numbers of salps. And Eugene Murphy talked about how that could lead to a shift from the dominant food web shown on the central panel, in which predators fed directly on krill, to an alternative food web where predators were feeding primarily on fish. But we had some suggestions of how things might work, but we didn't have the observations to say how they did work or how they would work in the future. As another example from the peninsula, as ice declined in parts of the western Antarctic Peninsula, ice-dependent species like Adelie penguins were declining, and open ocean foragers like Gentoo penguins were increasing. Again, we couldn't really say exactly how that happened. And the final thread justifying a Southern Ocean observing system was increased use of the Southern Ocean. We foresaw that at some point there might be an increase in fishing, an increase in exploitation of marine resources. Antarctic tourism was growing. Some of the numbers are there in the middle of the screen. As human use increased, the need for search and rescue capabilities would also increase, and the chances of oil spills or other disasters would increase. And there was also talk of geoengineering, in particular iron fertilization of the Southern Ocean, as a way to address the climate crisis. We were pretty uneasy about that because we knew that we didn't understand enough to know what the consequences or impacts of that might be, or efficacy for that matter. 2007 also marked the first Antarctic tourist vessel to go down, also increasing our focus on what human use of the Antarctic might mean. So we agreed, we decided a Southern Ocean observing system was necessary, and we had an idea of what we needed to measure. And the strategy laid out that plan. We needed repeat hydrography, and this looks very close to the WOS map I showed earlier, because the idea was that we needed to keep repeating that WOS baseline as the only way to detect changes through the full depth ocean of a wide range of water properties. Those don't happen very often, so we needed XBTs and underway measurements to measure things more frequently wherever we could. Seals would play an important part because they sample parts of the ocean that were very difficult to do by traditional oceanographic platforms, in particular over the continental shelf and in winter. This plot shows at that time what the coverage of traditional oceanographic platforms was, and shows how that is complemented by the sampling provided by seals. We knew we needed to do something about the deep overturning circulation, but it's hard. Part of it was repeat hydrography, but we also thought that we needed moorings along the key export pathways of Antarctic bottom water. It was a challenging ask. It was only partly, but was at least partly taken up. And while it was an observing system, we also recognized the need for the role that models would play. Atmospheric reanalyses had become a common tool. It's pretty unusual for atmospheric scientists to go to a particular radius-on measurement and analyze that. You analyze the reanalysis product that data goes into. We didn't have that kind of ocean reanalysis yet, but we saw it coming. And through Matt Masloff and others around the world, that forecast has come true. We do rely heavily on ocean reanalyses like the Southern Ocean State Estimate now to do our work, that integrate dynamics and observations in a way that we can't do to provide information that we can't get from observations alone. Forward models, non-assimilating models, were also important for the reasons I won't read the whole quote, but they allow us to do things that we can't do otherwise, expanding our focus in time, integrating observations, showing us where we need observations, and helping us to interpret change in terms of detecting change and attributing it to either human or other causes. So there's been huge progress over the past decade, and we'll hear much more about that during the week. This map shows a collection of a large number of different data sets, but the achievements of SEUS, as you will hear about, extend broader than just getting more observations of the Southern Ocean. They include making that data accessible, supporting researchers, both early career and otherwise, and supporting equity, diversion, and inclusion. I've been to a lot of SEUS meetings over the years, And I think the crowd here is about a factor of 10 bigger than we've ever had before, and I think that tells you really is another statement of the coming of age of both the Southern Ocean, our understanding of the Southern Ocean and its importance in understanding the Earth system, and also Seuss as a community. But I'll finish up with a few challenges, gaps, and surprises. The job, as far as we've come, the job is not done. First, we don't really have an observing system for the continental shelf and the exchanges between the continental shelf and the open ocean. It's hard, but it's also absolutely critical if we're serious about the understanding how the oceans might affect the future of the Antarctic ice sheet and therefore future sea level rise. We don't have a choice. We need to do this. The deep ocean remains poorly sampled. Deep Argo floats exist now. It's proven. It's technology that's out there ready to go. So far, it's not really been taken up by the Southern Ocean community much. We've made a start, but there's much more to do. The evidence that we have that the bottom layers of the ocean are warming, freshening, contracting, and slowing, this is where the big signal is. We need to measure the deep ocean. Air-sea fluxes remain very poorly observed. The map on the right from Sarah Gillies' Seuss paper on air-sea fluxes, the black dots are winter observations over a 5-year period, and there's nothing in the Southern Ocean, essentially. Seuss published a strategy for observing under sea ice, observing the ocean under sea ice and under ice shelves in 2014. We could make a map of what we thought was necessary and a schematic like this of all the tools that we could use to do that. We've made substantial progress, but there's still much more to do. And sea ice measurements are sparse and sea ice remains poorly understood. I suspect this figure may be the most frequently shown during the week, and I'm looking forward to an explanation of how it's happened, and I'm looking at you, Alex. We didn't know enough to anticipate that the overall circumpolar extent of sea ice would reach record highs in 2016 and immediately crash to record lows in 2022, let alone something like this year, where the sea ice is 5 or 6 standard deviations below the multi-decadal mean. These kind of surprises emphasize to us again how important it is to measure and understand the Southern Ocean. And Seuss is the way to do that. So a big thanks to all of you who have made Seuss a reality, and thank you for listening.
Everybody please join me in thanking Steve, and I'll ask him to come back to the stage if anybody's got some questions. So a quick reminder, if you don't want to raise your hand and ask your question verbally, you can also ask it through Slido. Has anyone got an opening question for Steve?
Thanks very much, Steve, for a fascinating talk and a really detailed background to Seuss. So I'm Sian Henley, current co-chair of Seuss, and my question is around the International Polar Year. So you said that the last IPY was really important in making Seuss happen in the first place. What do you think is the big opportunity that we should be taking advantage of coming into the next IPY at the beginning of the next decade?
I guess maybe it's because it's in front of my mind at the moment, but some of the gaps that I just pointed to, wouldn't it be wonderful if we really understood what controlled how much heat got across the continental shelves to the base of ice shelves and controlled the rates of melting? So we could address the largest single uncertainty in future sea level rise, which is what's going to happen to the Antarctic ice sheet. We've been talking about understanding the sensitivity of the overturning circulation, how it might change in response to a changing atmosphere above it and changing ice for as long as the period I've talked about, really. We're still not there. We still don't really know. And so as a result, we don't really know. It provides uncertainty to our projections of what's going to happen to climate in the future. And finally, maybe feedbacks and tipping points are something that are critical, are easy to talk about. They're easy to imagine how they might happen. but it's very difficult to understand them sufficiently well that it might give us some chance of anticipating them. And so maybe those would be the... Yeah, I think Kathy was first.
Thanks, Steve. So you mentioned that the ocean under the ice and the deep ocean are poorly observed. What would you recommend for getting better observations of those areas?
So I think we've got a pretty clear idea of what would be needed. So we should implement Deep Argo. So we have continuous measurements around the whole. We should do it globally. So we actually have global monitoring of the deepest layers of the ocean. We need to, the fact that the export of bottom water is concentrated in boundary currents, in a way makes it easy. We could put in focused mooring arrays in the pathways and we know where they are. And there's probably more to do in terms of understanding exactly how the various feedbacks and dynamics in the regions where these water masses are formed and exported, exactly how that works. So for example, we know that the salinity balance is crucial, and we know that precipitation, sea ice melt, ice shelf melt, did I leave something out? Are all important to the freshwater balance. But we're far from being able to quantify those individual terms and their sum in various parts of the continental shelf, and it's hard to see how we can really do that problem without that. Trevor.
The surprising area of sea ice is indeed surprising. Does the thickness of the sea ice matter, like it seems to in the Arctic?
It's critical, and despite talking about it for decades, we're not that much further along in being able to measure sea ice thickness at a circumpolar scale. So we don't know, I think. Well, there are some model and some ice state estimates now, I guess, that provide us with a map of sea ice volume. It's hard to know how good they are because we don't have any data really on much data on sea ice thickness that's going into that. Advances in satellite measurements of sea ice thickness and snow thickness I'm no expert in that area. It's been thought about for a long time and it may be getting us there. But I think the short answer is that we don't know to what extent the change in extent it goes, what the change in volume is that goes along with that.
Thanks for the talk, Steve. Following on from a few of these questions, you showed your figure from 2014 about what we needed to do to observe under the sea ice. We knew it then, we know it now. We haven't made a lot of progress in the last 10 years. Can you reflect a bit on what we can do differently over the next few years to really make that progress so we are getting good observations under the sea ice?
Yeah, there are a few things. First, it is hard. It's harder than in the open ocean, and that's part of why it's lagged. Part of it's been technology. While we had Argo floats, we weren't yet comfortable about being able to operate them under ice when we started. There's quite a few ice floats that have now been deployed in the sea ice zone, and it's clear that they, as Esme will talk about on Wednesday, I think, that they last for a long time. They can be positioned under ice. There are ways to do that, and they help fill a major gap. Not many have been deployed on the continental shelf. Those that have been deployed on the continental shelf have been immensely useful, so that they could be used more widely on the continental shelf. It's just a matter of buying them and getting them in the water. Under ice shelves is obviously hard, but the number of times it's increasingly autonomous vehicles are going under ice shelves, both floats and gliders and full-on AUVs. That's critical. Borehole technology is, we've recently, the first AUV was deployed through a borehole to collect measurements near an ice shelf grounding line. That was inconceivable not too many years ago, although it was at a SEUS meeting the under ice meeting actually, where we first heard people from Georgia Tech talk about how this might be possible. Personally, I think we might be able to exploit the resupply vessels more fully than we do now. If every time an Antarctic vessel crossed the continental slope and shelf made measurements of everything that it could, and that data was accessible through something like SEUS, that would be a step forward. A few days dedicated to that on each leg would be a major contribution as well. And there are more and more tools coming that would allow us to do more autonomously within the sea ice zone, and that's also important given how difficult it is to reach. And I should have mentioned moorings with data capsules. I think that's a major thing. If we don't have to get these things back, we could deploy them for 5 or more years at a time and get data back by pods that are released and talk to satellite. We know how to do that. We should do that in the Southern Ocean.
There was a question online. Given the ongoing challenges in global funding for ocean science, would shifting funding to Southern Ocean observations improve Earth modeling accuracy?
Sorry, just the last sentence.
Would shifting funding to Southern Ocean observations improve Earth modeling accuracy?
So one of the major biases in global climate models today is the fact that models get the clouds wrong. And as a result, they take up the whole radiation budget is off, and the impacts of that affect all latitudes, not just the Southern Ocean latitudes. Part of the reason for that is, well, we don't fully understand the source of the bias. One of the hypotheses is that biology in the Southern Ocean produces precursors, gases and particles and aerosols that lead to formation of clouds and formation of ice particles that contribute to the radiation balance. That's only one example of where a better understanding of the Southern Ocean is needed to improve global climate models.
Yes, Andrew Constable from the University of Tasmania. Steve, great presentation, thank you. Given your experience across many different organisations globally, my question is about funding. And something that we all need to think about over the coming week. The main advances that you showed in your presentation were the global initiatives, so the World Ocean Circulation Experiment, the Argo program, and so on. In this era of declining funding for Southern Ocean and Antarctic science, and we've seen it with the decline in the number of ships that countries are operating, and also science infrastructure. What advice might you have as we move through the UN Decade of the Oceans and move towards an IPY? How can we actually get the funding to a level when we can reach the aspirations that SEUS has and what you've described?
It's a good question, and one that I spend more of my time than I would like still thinking about. It is difficult. There are lots of calls for money. The programs that you mentioned were successful in part, I think, for 2 reasons. One, a very clear statement of the relevance and need, including the societal need, and that's probably even more critical now than it's been in the past. And second was coordination and collaboration. WOS and Argo and TOGA, all of these programs were seen as pipe dreams when they were first talked about, I think. It just seemed too ambitious. We would never get there given where we were. And so it pays to be ambitious, I think. It pays to have big dreams, but to have the sound science arguments to back them up, to justify them. And then to make it clear that this is something that the community really wants. It's not this handful of scientists over here. This is something that is widely viewed by the community as something that we just must do. And so that also helps get it over the board, get it over the line, I think.
Thank you for the opening, Steve. So I saw that the air sea heat fluxes remain poorly observed in the Southern Ocean system. So what are the advantages and expected outcomes for increasing the amount of observations at this interface layer within the ocean atmosphere?
Yeah, I think it's we're certainly in better shape now than we were in the past. Part of that comes from using the ocean observations to constrain models that include the atmosphere part so that we can actually infer what air-sea fluxes are consistent with the dynamics and water structure that we observe in the ocean. But we also need as many observations as we can get. Personally, I like the idea that the flux moorings are the gold standard, but they're very expensive, and they're difficult to maintain in Southern Ocean conditions. So I really like the idea of flux stations that drift. So spar buoys that are instrumented for to measure the lower atmosphere and the upper ocean at the same time, perhaps with autonomous vehicles, gliders flying around the spar to measure the subsurface ocean structure. That's much cheaper than a fixed mooring. And thinking of an ambitious vision that I hope gets realized someday, I could imagine a fleet of 20 of these that are maintained on a regular basis. And they would provide year-round measurements of the Southern Ocean fluxes in a way that we can't get any other way, I think. There's one over there, but we may need to move on.
Probably need to move on. No, yeah. So if you could all please join me again in thanking Dr. Steve Rintoul. So for the second part of our opening plenary, we've got Professor Eileen Hoffman, who's a professor and eminent scholar at the Department of Ocean and Earth Sciences and a member of the Centre for Coastal Physical Oceanography at Old Dominion University. Her research on understanding physical biological interactions in marine ecosystems was recognised by her election as a Fellow of American Geophysical Union. Her research has focused on a range of marine environments, most recently the continental shelf region of the Ross Sea and the Middle Atlantic Bight off the region off the east coast of the United States. Eileen contributed to the development of the Southern Ocean Action Plan that provisions the Southern Ocean community that aligns with the goals of the UN Ocean Decade. Professor Hoffman served as the chair for Integrated Marine Biophysical Research Project and is currently one of the co-chairs for the Southern Ocean Observing System. In addition, she has also been the chair for the Southern Ocean Global Ocean Ecosystem Dynamics Program. She's had lots of chair roles. Through her career, she's been committed to education of the next generation of marine scientists. And SUS has been very fortunate to have Eileen dedicated to the Southern Ocean Observing System for a long history, since our first science plan in 2010, where she was one of the authors, then joining our SUS Scientific Steering Committee, and then joining our Executive Committee in 2018. She served as our co-chair since 2020 and has been integral in SUS's current activities and contributions to Southern Ocean research. So please join me in welcoming Professor Eileen Hoffman. Thank you.
All right. So it's just the big green button, right? Okay, thank you. All right, I'd like to start by thanking Elise for her very kind introduction, and also thanking Sir Guy Green for his welcome and for opening the symposium, and to Steve Rintoul for a really excellent presentation on how we got here today. I also want to thank the SUS Symposium Program Committee for all their work in putting together this symposium, and also for the opportunity to give this presentation. I have the pleasure of serving as co-chair of SUS, along with Sean Henley as a co-chair, and also Amina Sloss and Seb Moreau as SUS vice chairs. And Elise is also a member of the executive committee, and she's the executive officer of SUS. But the most important co-author on my presentation is the SUS community, and that's why we're all here. And as we've already heard, the SUS is supported by SCORE and SCAR, And the International Project Office is hosted here at the University of Tasmania Institute for Marine and Antarctic Studies. And also there are a number of other sponsors or SUS that are shown on this slide here, and the support from all of these people or organizations is very much appreciated. All right, so as a presentation of what I'm going to talk about today, as shown here, there's an outline here. We've just heard from Steve Rintoul about how SUS was a perceived need by the scientific community and how it came about. So I will briefly mention the need for SUS as a starting point in telling you about the current status of SUS. I will then show how SUS delivers knowledge and data, and that follows from a comment made by Sir Guy Green, is that data is not. So, okay. So data is not necessarily knowledge, and you have to have the value added that turns it into knowledge. Okay, then I'm going to talk about some of the global connections and impacts of SUS, talk about the SUS community, and then maybe look to the future. Okay, so ocean observing is integral to our science. We all know that. Observing networks are expanding and providing extensive data sets, some of which we just heard about, that are being used to describe and understand the state of the Southern Ocean. All right, so SUS works across multiple large-scale international circumpolar observing initiatives, for example, Argo and the Ghost Ship, which are shown on this slide here, and also across some of the smaller scale regional, national observing and monitoring initiatives that are shown on the lower panel here to facilitate the integration and delivery of data. I'll call to your attention the plenary presentation this afternoon by Andrew Myers will expand upon the Southern Ocean circumpolar observations, and the plenary presentation tomorrow morning by Oscar Schofield will focus on the importance of regional observations and programs. All right, so if we move forward here, what is SUS and what it's doing? All right, well, SUS has a vision here. And this tells how SUS approaches the integration and delivery of data as captured in its vision here, which I will not read to you. But the important thing here is that SUS tries to ensure sustained observations that are readily available. And the way that vision is implemented is through SUS's mission, which is then to facilitate sustained collection and delivery of observations. Right, so that's where SUS is coming from. All right, so how does SUS's mission fit within what's shown here with the Southern Ocean Science Pathways? All right, so how do we work on this? So SUS interacts with these scientific pathways at the points here indicated by the red stars to enhance the collection and delivery of Southern Ocean observations. And the first one shown here at the top is that by aligning priorities across the Southern Ocean community to provide a unified voice. The second place here, shown by the 2 stars here, is by enhancing collaboration and observational capabilities through delivering integrative networks, collaborative tools, and facilitating improvements in observing capabilities. All right, and the next place here at the lower right-hand side here is ensuring the management and delivery of observational data that is findable, accessible, interoperable, and reusable, or adheres to the FAIR data standards. All right, and then the last thing here is that the knowledge gained from the Southern Ocean observations has to be made available not just to the scientific community, but to policymakers and stakeholders, because that's a very important part of the community that SUS strives to serve. So what guides SUS's mission? Well, we just heard that SUS now had its original science plan in 2011. That science plan was in effect until recently. So there is a new SUS science implementation plan that provides priorities and activities. And the way this plan came about was the community got together, there were discussions throughout a series of meetings and things, and there are 5 community-agreed science themes. All right, and what Steve Rintoul showed in his presentation were the previous science themes Those are now incorporated into the 5 that I'm showing here. And these are looking at, for the next 5 years, understanding the state of the variability of the Southern Ocean in the cryosphere, the circulation, carbon and biogeochemistry, ecosystems and biodiversity, and then looking at how you tie all this together through fluxes, all right? So as an example, the ocean, sea ice, atmosphere flux is something that goes across all of these themes. So this is what the science focus is now for SEUS. All right, so for each of the science theme, the community identified key science challenges, and I'm not going to show you these. I encourage you to look at the science implementation plan. What I'm showing you here are just examples for each of the themes, and these are the science challenges to look at over the next 5 years, but there are also some in here to think about for the next 10 years, all right, because we always want to be looking to our future. All right, and so SEUS works to enhance the collection and delivery of data required to address the science themes, but also the key challenges under each of the science themes. All right, and so in addition, SEUS has some foundational capabilities that it uses to bring together the ideas and data to address the themes and the challenges. And these are things like the data collection and delivery, which we're going to hear a lot about here this week, and also observing system design. There was a workshop yesterday that dealt with observing system design, looking at key variables, essential ocean variables as an example, modeling, setting methods and standards, and also the data management and data delivery. All right, so how do we do this? How is SEUS implemented? All right, well, we have several things we do here, but knowledge delivery is what SEUS is about. This is how we turn the data into something that's useful. So SEUS has a number of working groups that work to deliver the knowledge required to address the science themes and key challenges. Some of these are shown here. The Data Management Subcommittee oversees SEUS's data activities, which are core to SEUS. And the Data Management Subcommittee has workshops and presentations throughout the symposium that highlight its important contributions and activities. I encourage you to participate or attend those. SEUS has 5 regional working groups that give circumpolar coverage of the Southern Ocean, and the map shown here is roughly the areas that the different working groups focus on. And these working groups, like I said, have been based on region and interest of national programs, and the working groups undertake synthesis activities. And each working group not only has its members and its chair, but we also have early career researchers as part of all of these working groups, which is a point I'll come back to later. All right, so there are contributed sessions tomorrow and later throughout the week that describe the research results of interest for the SEUS working groups, these regional working groups. And the session on Thursday on circumpolar Antarctic ice sheet ocean observations is a collaboration among some of these working groups. So they not only work individually as working groups, but they collaborate across the working groups. All right, so SEUS also has what are in its knowledge delivery capability working groups, which enhance our capability in gaps in identifying and doing something about the gaps in the observing system. At present, SEUS has 3 capability working groups: the Censusing Animal Populations from Space, the Southern Ocean Air-Sea Flux, and Observing System Design. All right, and there are contributed sessions on Wednesday that highlight the activities of these capability groups. And as I said, there was the pre-symposium workshop yesterday for the Observing System Design, convened by the Observing System Design and Polar Tech. And there also, as Elise mentioned in her opening remarks, there are lunch meetings on Thursday. SEUS also has task teams, which are smaller groups that work with very short timelines, a few months or maybe a year or two, that focus on a topic. And then at the end of the task team's work, they either transition to a capability working group, or they just say we're finished and end their time. Okay, so an example of this is the Autonomous Underwater Vehicle Task Team that was recently completed, and then we now have a task team on polar technologies. All right, so the Wednesday afternoon plenary presentation by Noah Lawrence Salvas will highlight new observing capabilities, and there are a number of contributed sessions on this on Wednesday. All right, SEUS also works with the larger Southern Ocean community through partnerships and collaborations and national programs. Some of these are shown on this slide, and members of the SEUS community are participants or liaisons with these groups. I should note that the UN Decade is represented at the symposium, as we heard earlier, with a plenary session on Thursday morning, a contributed session on Thursday afternoon, and on Friday morning plenary, there will be many presentations about many of these partnerships. So this is an important, and I would say evolving area for SEUS, is the engagement in these international or in global partnerships and collaborations. Okay, so how does SEUS deliver its data? Well, we already heard in previous presentation about SEUSmap. All right, so this is the key product developed by SEUS to facilitate the delivery of data, and it's hosted and maintained by the European Marine Observation and Data Network, EMOD Physics, and SEUSmap is an interactive map of the Southern Ocean with aggregated data layers that can be turned on and off depending on what you want to look at. All right, so the example shown here is temperature data. And the different colors are temperature data from multiple sources, CTDs, SEALs, anywhere that you can get temperature data. And what's also shown on here is the real-time ice distribution, which is the blue line on here, and then for a reference point, the polar front is shown in purple. But you can add, mix and match, and move these in and out as you need to do, or you want to. And the upper panel shown here is where you add the layers that are of interest to you, the different parameter types, the different platforms, and then you can also download everything and use it. So as we heard earlier, you can learn about SEUSmap at the SEUSmap workshop on today, and there's another one on Thursday. So if you're interested in this, please go learn about it. It's a wonderful tool, and aside from facilitating science, I can tell you it's a great tool for teaching. All right, you can have your students do all kinds of cool things by going to SEUSmap. Okay, so another key product is Due South. And this is a database of upcoming expeditions to the Southern Ocean. And this is hosted and maintained for SEUS by the European Polar Board as part of their Polardex, or their infrastructure and logistics activity. And with Due South, you can search upcoming and past planned routes to the Southern Ocean, or you can put your own cruise routes in there, and we encourage people to do that. So this provides information on upcoming voyages, oceanographic programs, fishing vessels, tourism, and there is a workshop on Due South on Tuesday and another one on Thursday afternoon if you'd like to go in and learn about it. All right, so we got all of this information. We have all of this, we have these nice tools that allow us to get to the information. So what else do we do? All right, well, we add, the value added comes from the way the data are delivered to the community. All right, and most of us are academics, so publications are one approach that we do, and some of the key publications are shown here. The publications provide results from our working groups, and as shown on the top panel here, they range from synthesis of science of the state of art in a region, to improving ocean flux measurements, to data management best practices. And I'll say that that's one thing that SEUS has taken a lead in through the data management subcommittee, is putting forward the best practices for data and data use. And I encourage you to look at that. There are contributions from the SEUS community, from all of you here, come out through the Science Implementation Plan, the data policy, and also the structure, excuse me, of the observing system, which are shown here. These are publications. And SEUS has an annual, has inputs to the annual State of the Climate report for the Southern Ocean. The SEUS input is for that. That's published in the Bulletin of the American Meteorological Society. So this is the value added. This is how you get the information from the data back out to the community. All right, but the other thing is SEUS has a reach and impact that goes beyond just Southern Ocean data delivery. Our SEUS members have been actively involved in developing the Southern Ocean Action Plan for the UN decade, and we'll hear a lot about that later this week in the plenary session on Thursday morning. And there are a number of activities about how SEUS is going about involved in the implementation of the Southern Ocean Action Plan, which you can learn about. Another activity, MISO, shown at the top here, has been led by Andrew Constable, who's the former co-chair of SEUS, and it's looking at the long-term status and trends in Southern Ocean marine ecosystems. And MISO is now finalizing a summary for policymakers, and the figure shown on this slide is from that summary. And there's a presentation on MISO on Wednesday, and it will be highlighted in the Friday morning plenary session. All right, and also SEUS has been very well represented in the UN Climate Conference, COP26 and COP27, shown in the photograph here. And the person standing there making the talk is Sean Henley, the co-chair of SEUS. People sitting on the stage behind her are members of the SEUS Scientific Committee, Steering Committee, or members of the SEUS community. All right, so this photo is from COP26. And SEUS has also been represented through Sean's efforts through the UN Conference, Ocean Conference 2022, and plans are currently being developed for COP28 to strengthen SEUS's impact at a higher level. All right, and Indy Hodgson Johnson will give a plenary presentation on Wednesday morning about the importance of observations for policy and society, and we heard about some of that this morning from Sir Guy Green in his presentation. So this is how we move beyond just our own science and get this information out to the larger community. Okay, so who does all this work? All right, well, it's the SEUS community. And as Steve mentioned in his presentation, SEUS has been in operation for some time, officially since 2011. And SEUS celebrated its 10-year anniversary in 2021, which is shown here. It was an online celebration because of COVID, but even with that, it was extremely well attended, given the time zones and all of that. People made an effort to participate in. But in the first 10 years, SEUS has built a community network that has continued to grow and develop itself, its own integrated networks and coordination, and we're all here because the SEUS community is growing. All right. So, well, let me see if it'll turn. There we. Okay, but as part of this community, SEUS made an important step when it recognized that developing a vibrant and engaged community was possible only if all of the activities SEUS undertakes are equitable, diverse, and inclusive. So SEUS established an equity, diversity, and inclusion group to provide guidance on how to do this. All right, the EDI group actually developed the code of conduct that we heard about from Elise's presentation this morning. And they came about with a low-cost hybrid option for the symposium, and that was the streaming that some of the sessions that Elise mentioned for some of the sessions. And I will say that it was good that they were able to do this because it gives us a broader reach for the symposium. The members of the EDI group are also involved in the UN Decade EDI activities. All right, so there is a plenary session tomorrow on equity, diversity, inclusion, and Southern Ocean research. And the other part of this is the early career researchers who are the future of SEUS. The SEUS groups work to involve early career members in leadership positions as well as members. And SEUS works closely with APEX, the Association for Early Career Polar Scientists, to find and identify people who might be interested in these positions. If there are any early career researchers here who might be interested, please contact Elise, anybody, any member of the SEUS steering committee, whatever. Just make yourself known, because we're always looking for these people. All right, and there is an early career researcher networking event this evening, and there's also a mentoring program that will be going on throughout the symposium, and we can thank our EDI group for helping setting all this up. So the SEUS Science Steering Committee provides, and the Executive Committee provide oversight, guidance, and advice for SEUS activities, as well as initiating new activities that advance the SEUS mission. So again, if you're interested in these types of activities or becoming involved at this level, please just make yourself known, because again, we're looking for people who want to be involved. All right, so SEUS functions as well as it does, and believe me, it does very well, because of the International Project Office and its amazing staff. Elise and Julia keep things coordinated and moving forward, as well as providing connectivity and continuity to the SEUS community. All right, the SEUS data officer position is open. If anyone is interested in the position, please talk to Elise or any member of the data management subcommittee or anyone on the SEUS executive committee. And I can't tell you what a pleasure it has been to work with the IPO here. They're just wonderful. All right, and as we've heard several times, the IPO is hosted here by the Institute of Marine and Antarctic Studies at the University of Tasmania, and the support is critical and for SEUS and is very much appreciated. All right, so the last bit here, we're here at this symposium, and who is here? We have 295 registered people, 21 countries, and more than 200 institutions represented. The pie chart over here gives a breakdown of career stage, and the one that I think is most important, more than 30% of the people here are early career researchers, and that's great. And you can see the distribution of the countries these people are, the people here at the symposium are from. Okay, so to end up here, what about the future of SEUS? We know that that there will continue to be advances in observing capabilities, observing systems. We heard a lot about that in Steve Rintoul's talk. And these capabilities will take many and varied forms and provide many and varied data types. All right, the integration and coordination of these data and providing access is fundamental to the development of Southern Ocean research. All right, SEUS and the SEUS community are well poised to take the lead in ensuring that these data systems will provide the observations that are needed to understand and project changes in the Southern Ocean and the consequence for the global ocean system. All right, and that's what we're showing. What's shown here in the schematic on the upper panel here is what we're looking at for the future of observing capabilities. And as Steve mentioned in his talk, it's been an amazing development since the initiation of SEUS, which is shown in the panel here. All right, so as part of the future of SEUS, we're excited to announce that we have a new collaboration for the sponsorship and hosting of the SEUS IPO in 2024. The Institute of Marine and Antarctic Studies, the University of Tasmania, CSIRO, the Tasmanian state government will continue to sponsor the IPO, but we have the addition of new partners, the Australian Antarctic Division, the Australian Antarctic Program Partnership. All right, this support was very much appreciated, and not only because it allows us to continue, but because it is a vote of confidence or a statement of confidence in SEUS and what SEUS brings to the community. All right, so we thank our international sponsors for their continued support, and these are shown here as the Swedish Polar Research Secretariat, Antarctica New Zealand, Turkey's Polar Research Institute, the University of Cape Town's Biogeochemistry Lab, and Ocean Ice. So with that, I'm going to end. Thank you for your attention. I hope you enjoy this symposium, get to meet new people, go home with new ideas, and go home thinking, yes, we need SUS, and I want to be a part of it. So thank you very much.
Thank you, Eileen. Does anyone have any questions for Eileen? And also a reminder, you can put it on the Slido at any time during the talks if you want to.
Hi, thank you for the talk. Congratulations on the funding. I have no idea about how these things work, and I was wondering if you could give some insight. Is it difficult to get continuing funding like that? Or maybe it's easy?
I can speak with the perspective of having been a co-chair of 2 or 3 of these international programs. Funding is always a struggle. And I think it's always a struggle, but we can usually find a way to go forward. And I think when you have a program like SUS or Ember or any WOS or any of these things like that, that deliver a product or products that the community wants and needs, it helps then on the other side to go to the funders and say, this is what we would like, this is what we're doing, this is why you should put your funds into this program. And I can speak with a U.S. perspective, is that it is difficult to get long-term sustained funding. Other countries may be different, but it's a continual process. You're continually talking to people, you're continually putting out, explaining what you're doing. And I think in some sense that's good, because it makes the program the project continue to develop products and data and outputs that then people want. And I think that's also another reason why it's so important to have activities or to have products that are of interest to policy and regulatory communities or regulatory organizations, because ultimately I think those are the groups that are making the funding decisions. So, but it can be done. I'm not saying it's easy, but it can be done. So, yeah.
Thank you, Eileen. Great talk. So, one of SUS's goals is long-term sustained observations, and there are some great examples. Argo, MEOP, GoShip are all doing it. But many of the regional programs, I think, are somewhat disparate. What do you think the role of SUS is in trying to get the regional programs to, kind of unify their observations and really make them a sustained Southern Ocean observing system?
So that's where the regional working groups are very important. All right, within the regions, they work on those types of issues, and then they work across the regions to see if to attempt coordination and standardization and that type of thing. And that's really, I think, what you just said is why SUS has these regional working groups, and they've been very effective in what they're doing. So, but yeah. Okay.
Thanks, Eileen and Sean, for running everything. I guess, other than funding, what is the other things that maybe keep you up at night that hopefully we can resolve this week so you sleep better?
What keeps me up? So, Oscar, there's so many things that keep me up at night. Right, and I can say SUS isn't usually one of them. But so, what What I would like to come out of this, not just my personal thing, but I think one thing to come from this is coordination and just understanding what is going on in a circumpolar sense. And I say that because when we get to I don't want to get ahead of things here, but when we get to talking about things like the UN decade and things like that, there are, with the Antarctica in sync and those kinds of activities, what those are attempts to begin the coordination of a coordinated circumpolar observation science program. And I would hope that when we come out of here, we can understand what that might be, what the focus might be, and then how SEUS can the SEUS capabilities can be used to make sure that those programs are in fact successful. But I think that's it, is to take maybe a broad circumpolar view of the science questions, the data, and then where we can make an impact on that, right?
So thank you very much, Eileen. If you could all join me in thanking Eileen. I notice... I see there was still a few hands in the air, so I'm sure you can find Eileen during the morning tea to answer any questions, or also on that regard, anyone from the SEUS Executive Committee or Scientific Steering Committee. So before we break for morning tea, just a quick reminder, we now go into our 3 parallel sessions. So we've got Creating Impact for Observational Data Beyond Research workshop. We've got a parallel session on Southern Ocean sea ice variability in a warming climate, and then a parallel on human engagement in the Southern Ocean. When you go to leave here, if you could please all take your belongings with you and exit the room, because we actually have a wall coming in through the morning tea, so we need to allow space for the hotel to be able to move that wall in. Reminder for anybody in the mentoring program, grab yourself some morning tea, then come join me over that side of the mezzanine so we can buddy up your mentors, mentees. And lastly, for the ECRs, remember those 2 tickets you've got, one for yourself, one for an invited guest. If you're not an early career, side up to an early career if you want to come along tonight. And I hope you all enjoy the rest of today and the symposium. Thank you.